All right, so now we are ready to look at our 4-4 lesson, get some additional practice. The first three problems are asking for us to find the sum. So what we need to remember with adding and subtracting rational expressions is that we are adding and subtracting fractions, which do require a common denominator. Okay, so let's take a look at number 4. Find the sum. We're adding these two fractions together. When we Well, yeah. First, look at the denominators. I thought we were going to have to do a little bit more work for this one. If you already have a common denominator, then you're ready to go. So this was kind of a nice one to start out with. We already have the common denominator, which means that this y squared minus 5 will be the denominator of our answer. The numerator, what we're going to do is we're going to add the like terms. So I think what I'm going to do is I'm going to write out a little bit more than I normally would just so we can kind of, I don't know, just so it makes sense. So there's my 6y minus 4 plus the 3y plus 1. So here's our answer. We want to see if we have any like terms we can combine in the numerator. The 6y plus the 3y would give us 9y. Negative 4 plus 1 is minus 3 all over y squared minus 5. From here, we always want to see if we can simplify this fraction, which means reduce factors. So can we reduce any factors? The numerator does factor. There's a GCF of 3 we could factor out. It leaves us with a 3y minus 1 over this y squared does not factor, so we're going to leave it as, the y squared minus 5. This is not a difference of squares. We talked about different squares a couple times on the last page. This is the difference of a perfect square, and this 5 is not a perfect square. That's why that does not simplify, or does not factor, excuse me. So now that our answer is factored, do we see any factors that we can reduce? I've got a 3. I don't see a 3 down here. There's 3y minus 1. There's not a 3y minus 1 down here. There's a y squared minus 5 in the denominator. There's not a y squared minus 5 in the numerator, so we are done. There's no simplifying we could do. But we always want to try to, because if you can reduce a fraction, we reduce our fractions. We always have, and we will continue even when they look like these. All right, so number 5. We need a common denominator. We don't know right now. First of all, they're not the same. We don't have a common denominator. But what we don't know is maybe some of it is common. Maybe they have some common parts that we're just not aware of. So what we like to do is rewrite the problems with the denominators factored. That just makes it a lot easier to find a common denominator or to get to the common denominator. So this x plus 2 numerator doesn't change. I'm not worried about the numerators yet, but the denominators, x squared plus 4x plus 4, factors of 4 that add up to 4, that's going to be a 2 and a 2. So x plus 2 times x plus 2 plus 2 over x plus 2. All right, well, first of all, if you can reduce a fraction before you add it to anything, go ahead and do it. This first fraction, I have an x plus 2 divided by an x plus 2. I honestly didn't think far enough ahead to realize that was going to happen, but that's kind of nice. So if you can work with reduced fractions, go for it. Our new fraction, if we reduced everything from the numerator, there is still a 1 up there. And then this x plus 2 is going to stay x plus 2 plus 2 over x plus 2. And then the reason why that was kind of nice is now we actually do have a common denominator. So we keep our denominator. We're going to add our numerators. See if you have any like terms, which we do, so we end up with a 3 over x plus 2 for a final reduced answer. That's not going to simplify any further than that. Well, that one went faster than I was expecting. This was kind of nice. Keep an eye out for that. If you can reduce your fraction before you add it to another fraction, why not? Okay, number 6. So we are adding fractions. We need a common denominator. Right now, we don't know if we know they're not the same. Like as I look at them, those are not the same. But maybe they have some common parts. Let's look at these denominators in factored form and see how it looks. So the first fraction, we have our 4 over x squared minus 25. That's that difference of squares. We are subtracting two perfect squares. So x plus 5 times x minus 5 plus 6 over, all right, x squared plus 6x plus 5. Do we have factors of 5 that add up to 6? Yeah, 1 and 5. So x plus 5 times x plus 1. Okay, so let's talk about let's talk about it. All right, do we have anything that's common already? So do you see how we have this x plus 5 and this x plus 5? So they already have a little bit of a common denominator or parts that are common, but we need to get the rest of them to be common. So we can get a common denominator with multiplication. I can see that this fraction on the left has an x minus 5 in the denominator, and this fraction does not have an x minus 5. So what I'm going to do is I'm going to multiply in an x minus 5, and as long as I do that to the numerator also, then it's okay. I'm essentially just multiplying by 1. But how that helps us is now both denominators have an x minus 5. So they're almost exactly the same, except this one has an x plus 1, which means we're going to multiply in an x plus 1 over here. So let's multiply in an x plus 1, but we have to make sure we do that to the numerator also. And then what we notice is now both denominators have an x plus 1, and now we have a common denominator. So when you have a common denominator, you know what the denominator of your answer will be. It's going to be an x plus 1 times an x plus 5 times an x minus 5. Now the numerator is going to be all of this. An x plus 1 times 4 plus a 6 times x minus 5. Now, it's going to be very tempting to cancel these and cancel these. But because of this plus in between, we cannot. We actually are going to simplify the numerator. We're going to do some distributing. So our numerator has a 4x plus 4. We're going to distribute a positive 6 plus 6x minus 30 all over this denominator. I'm not going to rewrite it right now because I can see that we can combine like terms in the numerator. 4x plus 6x is 10x. 4 minus 30 is a negative 26 over this whole denominator again. Now I'm just being lazy, but for our final answer, what we want to do is see if we can do any reducing between the numerator and denominator, which means can we do any factoring and get our factors to reduce. So 10x minus 26 does have a GCF of 2. That will leave us with 5x minus 13 over, now I am going to write in that common denominator, that x plus 1 times x plus 5 times x minus 5. It's just so long, I didn't want to rewrite it that many times. Do we have any factors we can reduce between the numerator and the denominator? And if you look carefully, we do not, which makes this our final answer. All right, let's get to our subtraction. All right, when you subtract fractions, you need a common denominator. Do you guys see how this one has a negative out in front of this fraction? When that happens, just tack the negative to the numerator. So really this is a negative 2 over n plus 4 minus n squared over, let's factor that denominator. N squared minus 16, it's a difference of perfect squares, so that will factor into n plus 4 times n minus 4. Now that we have our denominators all factored, what we notice is they already have something in common. They already have the n plus 4. So what do we need to make both denominators the same? This n minus 4 we need over here. So we're going to multiply in. I'll go ahead and put parentheses around that. We're going to multiply in an n minus 4. Maybe this one I'll multiply it in behind it because that's kind of what it's going to look like. All right, so now we have a common denominator of n plus 4 times n minus 4. Now the numerator, we have all of this going on. We have a negative 2 times n minus 4 minus an n squared. So can we do any simplifying with that? Yep, we want to simplify the numerator. We're going to distribute that negative 2. So we have a negative 2n plus 8 minus an n squared all over n plus 4, n minus 4. Let's keep working with that. This is out of order. I would like this term to go first. That negative n squared minus 2n plus 8 all over n plus 4 times n minus 4. Let's see. We want to see if we can get any factors to reduce, which means we want to factor this numerator. But do you guys see how that is a negative n squared? Let's factor out a negative 1. So we have n squared plus 2n minus 8, and then we want to see if that trinomial will factor. All right, do you guys feel like this is the never-ending problem? I mean, how many lines of work can I do here? All right, so negative 1 times factors of negative 8 that add up to positive 2. It's going to be an n plus 4 times an n minus 2. All right, so yeah, that does factor over n plus 4 times n minus 4. Okay, well that was worth it because do you notice that we have an n plus 4 divided by an n plus 4? So now our final answer, we have a negative 1 times n minus 2 over n minus 4. Whew, we made it. All right, let's see if we can get our next one with a little bit less work. So what I noticed first and second, I noticed a couple things. This negative, let's tack it on. Let's see that as a negative 3 over. Now 8x cubed, y cubed. There's no addition or subtraction, which means we can't do any factoring there. Minus 1 over 4xy. That's another monomial. Can't do any factoring. So we're ready to start seeing what we can do to get a common denominator. We're going to look at one part at a time. This has an 8, this has a 4. Why don't we multiply this 4 times 2 times 2, and now we have an 8, and this will give us that same 8. So that's the same. Here we have an x to the third power. Here we have an x to the first. Well, why don't we multiply in an x squared also to the numerator because x times x squared is x cubed, which is the same as this. So now we have the x cubed is the same. All right, this is a y squared, excuse me, y cubed. This is a y. We need more y's over here so we can multiply in a y squared also to the numerator. So now we have a y times y squared, which is y cubed, which is what we have over there. So we have a common denominator. Okay, so this one, why don't we clean it up a little bit? Negative 3 over 8x cubed y cubed minus, if we multiply that second numerator, we have a 2x squared y squared all over 8x cubed y cubed. All right, so we are subtracting fractions. We know that we will keep our common denominator of 8x cubed y cubed, and then we're going to subtract the numerator, negative 3 minus 2x squared y squared. Can we do any simplifying with the numerator, any factoring to get any factors to reduce? And there's no GCF. It's not a difference of squares. We cannot factor that. So this will be our final answer. I guess we did get there a little bit faster than number 7, but. All right, last one for our 4-4. Let's see. We are subtracting fractions. Let's take a look at this problem with some factored denominators because maybe they already have something in common. 4y plus 8, we can factor out a 4, leaves us with y plus 2, that had a GCF, minus 1 over y squared plus 2y, we can factor out a y, and it leaves us with a y plus 2. All right, do they have anything that is already the same? Oh yeah, they do. They both have a y plus 2. All right, so I can see that we have a 4 on the left, so let's multiply by a 4 on the right. Just make sure we get the numerator multiplied by 4 also. So now they both have a y plus 2 and a 4. This one on the right, though, has this y out front, so we need to multiply in another y over here. So I'll go ahead and multiply by y and also to the numerator. And now we have a common denominator. All right, so we know that our denominator will be a, let's see, a 4 times a y plus 2. So I'm just going to say 4y times y plus 2. And then the numerator is y times y minus a 1 times 4. Y times y is y squared minus 1 times 4 is 4. All right, well, we definitely can simplify this answer. I see a y squared minus 4 in the numerator. There's that difference of squares. We are subtracting two perfect square terms. That's going to factor into y plus 2 times y minus 2. The denominator can't do any factoring there because we were working with factors, so it is already in factored form. Do we see anything that we can reduce between our numerator and denominator? Y plus 2 will divide by y plus 2, and that is all we can do. So our numerator has a y minus 2, our denominator has a 4y, and there's our final answer.